Welcome to today's webinar, MySQL Advantages for Delivering an HA and Scalable Database Solution. Our speaker today is Srinivasa Krishna, Senior MySQL Database at Datavail. Krishna has more than 11 years of experience in the IT industry, including 8+ years as a MySQL Database Administrator with Datavail Corporation. He specializes in MySQL Database Administration and technologies like MongoDB, Amazon Redshift, and Linux administration and scripting. He also specializes in database architecture, DBA, HA solutions, performance tuning, and managing enterprise-level database support. Before we begin, I would like to remind the audience to please feel free to submit questions throughout the event via the question chat box on your webinar toolbar. Our speaker will leave some time at the very end of the presentation to address these. I would like to now turn the call over to today's presenter. Please go ahead, Krishna.
Thank you. Good morning, everyone. Thanks for joining us today. Today we're going to discuss about some of the MySQL advantages and what options we have in delivering a highly available and scalable database solutions using MySQL. Okay, before we actually get started with the presentation, a brief introduction about myself, Srinivasa Krishna Mamillapalli, Senior MySQL DBA at Datavail. Having 10+ years of DBA experience, I've been with Datavail for more than 8 years. It's amazing. All right, about Datavail. Datavail is one of the largest pure-play database services provider in North America with more than 300+ client base, and we do have more than 400 DBAs across the globe. And here is the list of some of database services that we support. So before we actually get started with the presentation, I want to highlight some of the main challenges in the database world. And obviously, the first and foremost thing is the availability portion. So we need to make sure that the data is available to the users whenever and wherever they want it. And it's not just available, but they should be able to get the data whenever they need it with high performance. They need to make sure we get the data available to them, with the minimal resource requirements as possible. So it's not just the availability of the data. We need to make sure they get the most valid and reliable, consistent data whenever they're needed. We need to make sure they're not getting this stale or latency data that is of no use. So the next thing is the most challenging part is the scalability part, because the data volumes got changed, and the requirements have changed dramatically, and we are seeing gigantic gigabits of data coming in daily. So the solution that we're going to implement should be able to meet all these challenging requirements and the demands for the application. And not only the scalability portion, but we need to make sure the solution that we're going to provide or implement is most cost effective. And the most important thing is about the security, and we need to make sure the data is not in the wrong hands, and only the valid users should have access to the required data. So now let's take a look at how MySQL is able to meet or overcome some of these challenges, and what options we have in delivering a highly available and scalable solution. So here is a quick overview of the MySQL Evolution. So you can see that some of the milestones in the MySQL version history here. So MySQL was initially developed by a company called MySQL AB, which is in 1996, and later, Sun acquired this MySQL AB company, and in 2008, and again in 2010, Oracle acquired Sun Microsystems, and those MySQL with Oracle. So it's pretty interesting, the series of events that took place over these past 20 years, and ever since Oracle acquired Sun Microsystems and MySQL, there have been tremendous movement, and there are so many open source community groups that forked MySQL and developed into the product that it is right now. And Oracle has made tremendous improvements in making MySQL more reliable and robust, the product it is right now. And okay, so not just Oracle, but there are other open source community groups like Percona, MariaDB, and other companies like Facebook are Facebook, Google. They also customize MySQL and they enhance the product to make sure all the requirements are met, and the goal is that to make the product more robust and enhanced with all the new features. So undoubtedly, MySQL 5.6 is one of the most stable and reliable version loaded with lots of features and enhancements. Uh, and the most awaited MySQL 5.7 has become GA in the last couple of months, and it has some exciting features too. We're going to go over some of these new features and in the upcoming slides. So let's take a look at what MySQL has to offer, what advantages that MySQL has when compared with other databases. Well, first and foremost is it's very easy to install, manage, and maintain. So we can have the MySQL database instance or server up and running in less than 10 minutes of time. And it's very portable, so we can have the MySQL server running on any hardware or virtual platform available out there in the world. And it requires some minimal resources, like we can have the MySQL instance up and running with as minimal as 250 megabits of memory. So it's pretty flexible and convenient. So one of my most favorite feature is the pluggable storage engine concept. It's pretty much like we can convert the data from one engine to another engine, and however we want to store the data, we can certainly do that. We don't have to stick with one set of data sets. So MySQL offers multiple security layers. So we can talk about some of those security layers and how we can make sure with the current increased cyber threat attacks. Undoubtedly, it is one of the most popular open source database solution out there in the world. Open source means it's free, it's cost effective, and we can save tons of amount of money on operational management and licensing cost. Okay. Irrespective of the type of the application, whether the application is, as a high-end transaction processing system or a website with billions of queries a day, MySQL can meet these performance expectations and offers rock-solid reliability and availability around the clock. Okay, MySQL also provides support for every application development need. So if you have like embedded applications, there are plugin libraries available to embed MySQL into any type of the application. All right, these are some of the main advantages, and because of its nature, MySQL has been widely deployed by many organizations around the world. Okay, here is a quick look at some of the MySQL customers and some of the main players in the technology world. So most people would ask, okay, we know MySQL and we're not sure why and where MySQL solutions are being used. Well, the answer is pretty simple. MySQL is used in almost all solutions, starting from blogs, websites, static content to shopping cart, WordPress, e-commerce, and now as it became more mature, it's being used even for online transactional processing systems and data warehousing, and now software as a service, platform as a service, and even infrastructure as a service. So it's everywhere. So those who are already aware of MySQL and open source platform, here is a pretty picture about MySQL architecture. So you can see that this particular architecture has multiple layers. See, it supports various application connectors, and it has a user authentication protocol set up, and the SQL parser and everything. So the beauty of the pluggable storage engine concept is that we can choose the type of storage engine that we want to use for the type of data, and of course that depends on the application needs, and each storage engine has the APIs associated, so that way they can work independently and without have to be dependent on any other And the beauty is that each of these storage engines have their own multiple cache layers. So it could be either global cache or per thread cache. So that can be used for the specific storage engine and allocation. So when it comes to the file system, MySQL supports almost all major file systems out there, including XFS, GFS, and it can also support SAN and NAS storage. So MySQL has multiple logs available. So if you're looking for MySQL error log, undo logs, and binary logs, which is one of the most important for any HA solution. So we're going to talk about how these logs and replication and all these things work in the upcoming slides. And you can see that it has some enterprise level utilities and stack of tools that would help for the DBAs to manage the day-to-day activities. Okay, so let's talk a little bit about the storage engines. Okay, we know that there are multiple storage engines, but we don't know which one to use. Well, to start with, each storage engine has its own unique features, and over all these years, MySQL is undoubtedly one of the fastest and high-performance storage engine because of its B-tree indexing nature. And much effort and improvements have been put by Oracle and other groups to make sure InnoDB is also brought up to the performance levels of MySQL, and especially with the 5.6 and 5.7 versions, all these enhancements made to InnoDB storage engine, it can meet all these performance metrics of MySQL now. So what would happen, how do we decide which storage engine to use? Well, each storage engine has its own unique features, and of course some of the dependencies and limitations we need to consider. And we're not going to go over each of these individual storage engines in this presentation, but we'll give a quick overview of the features and comparisons. So MySQL is pretty much like a non-transactional storage engine for a high read-only traffic, and it's very fast. And if you're looking for transactional support and with all ACID levels and everything, we need to go for InnoDB or ExtraDB or any kind of transactional support storage engine. So here is a quick look and comparison of the storage engines and their limits. For those who are interested, you can refer to more from MySQL documentation. So most people would ask, okay, we have all these storage engines, but we don't know which one to use. Well, up to 5.6, I believe we have MySQL as a storage engine, default storage engine, but starting from 5.6, InnoDB is the main storage default engine. So if you're not sure which one to use, I would suggest we go with the default. And it's not like that we have started with InnoDB and we have to only use that. Well, the beauty of this pluggable storage engine concept is we can swap whenever needed and however needed. So we can enable and disable the storage engines at any time, and all this needs is like configuration, and we just need to convert from one table to another type. Okay, so let's focus on the transactional support storage engines. So there are 3 different storage engines that would support the transactions, and of course we're not talking about the network database storage engine. That's for the cluster database architecture. We're going to talk about a little bit more about that NDB storage engine in the next slides. So InnoDB is undoubtedly one of the most popular transactional safe storage engine, which supports all the ACID levels and multi-version support. So if you're looking for the transactional support within your application database, obviously InnoDB is the storage engine to go with. So InnoDB is developed by Oracle, and there are enhancements made to this InnoDB storage engine, and Percona, they are also one of the active development in the MySQL world. They have enhanced InnoDB, and they made a fork called ExtraDB, which is a default storage engine in their Percona Extra database. And TokuDB is also one of the the fourth version. It supports the transaction storage engine, and it offers high level of compression, and with a much more uh, speeds in performance. So we need to be a little bit cautious about using this TokuDB storage engine because it doesn't support the foreign key relationship. So if you have this kind of foreign key relations, obviously we might have to look for another way of dealing with that. All right, so what would happen if what are the main advantages of TokuDB? So because of its what do you call a bit clustered storage engine, because of its clustered indexing format, and InnoDB has some of the overheads, the way it has to support all these multi-versions, and the size of the indexing, and the dependency on the secondary key indexing and everything. That's pretty much kind of an overhead, and there are enhancements being made to InnoDB with all the plugins and compression protocols enabled. But to overcome this, TokuDB has a different methodology called fractal tree indexing. So the fractal tree indexing, what would happen is it would significantly reduce all these overheads, and it can offer like up to 80% reduction in the database size and index sizing, and without compromising on the performance metrics. So we recently had a customer where they were having their database size grow into multiple terabytes, and they started seeing this performance issues with all this relations, and data size grew, and IO issues and everything. So we helped them migrate from InnoDB to TokuDB, and the results are pretty amazing. Like without compromising on the performance, we were able to gain huge storage volumes, and even the performance improved quite a lot. Okay, these are some of the objects that are supported in MySQL. MySQL supports different type of storage engines, like including the B-tree, bitmap, and even geospatial indexing. So MySQL supports store functions and store procedures. It has even database triggers enabled, and it doesn't still have the DDL triggers. Currently, it only supports the DML triggers. So probably that's something for the newer future versions. So MySQL also supports the event scheduler, so you don't have to rely on the operating system task scheduler or cron jobs. We can even schedule these events from the database and trigger them. Okay, let's talk about some of the high availability options we have in MySQL. Well, the most reliable is the MySQL replication. So before we actually get started with the replication, I wanted to give a brief introduction of how this replication works. So on a high level note, the replication for MySQL is pretty much the way it works is on a level of a log shipping and with a series of events. So let's assume you have a master server, and that's a standalone server, and if something happens to the database, we don't know, we don't have a solution in place, so we should be able to restore and recover except the last backups that we have. So what happens if the site goes down and if we want to still have the application and data to be available? Well, the obvious thing is to do is make sure you have a replica set available for the data sets. So the way replication works is you have all these operations or transactions that are written to the database. So MySQL stores them in the form of binary logs, and that's something we need to enable. And binary log is something like with all these series of events that happen to the database, they'll be logged inside, and they'll be shipped over to the secondary site, and they would be reapplied on the target server to make sure all the data is available and in sync across the secondary slave. So in case of a master failure, we still have a place to go and look for the data to be available, and for us to perform the operations. So there are multiple bin logs. So the way the bin logging works is up to 5.1, I think we have only statement level bin logging. So that means each statement as it got executed on the master, they'll be returned to the binary log, and they'll be reapplied on the target site. So there are multiple threads that would happen in the replication. So master would as soon as it's written to the binary log, it will be sent. The log event should be sent from master to the secondary side. On the slave server, which is we call the secondary, we'll have two different threads running for the respective master. So the first is a slave IO thread that would just simply capture the data that was sent from the master, and that would be returned to the slave's relay log on the slave server. So these are pretty much like the series of operations that we have from the binary logs on the master. They'll be called relay log events on the slave. And there will be another thread called slave SQL thread that would apply these relay log events on the secondary slave. So that's pretty much how it used to work, and because of some overheads and the latency that is caused because we have to reapply all these transactions again on the slave, there have been changes made to the binary log types. So there are called mixed mode and row-based events. The row-based events is instead of sending over all these SQL operations as it is, what would happen is only the modified blocks or row events or row IDs would be sent over, and they would be applied on the target. So this reduces the overhead and latency that is part of the replication. So that's pretty much how the MySQL replication works on a high level. And basically, MySQL replication is pretty much like a asynchronous replication, and so that doesn't mean that it's synchronous, and as soon as the operations performed on the master, they'll be applied on the slave server. So it's being single thread, so there might be some latency that need to be taken into consideration. So there are improvements and enhancements made to the replication process. So even there is a plugin called semi-synchronous replication plugin available, and MySQL can even perform delayed replication if you're looking for any kind of reporting. So semi-synchronous replication, the way it works is pretty much like a transactional acknowledgement. So as soon as the transaction gets committed on the master, that's got returned to the master, there will be an acknowledgement sent out to the secondary slaves to make sure whether this transaction is received. So as soon as the transaction is received on the slave would send an acknowledgement back to the master saying that, okay, now I have. So that kind of a delay or a latency is there for this semi-synchronous replication. So with replication, there are multiple topologies that we can go with. So we have master, slave, master, and chain replication. So you can replicate from A to B, B to C, and this can even go with a master, multi-master, and circular replication. Unfortunately, there are some constraints until 5.6 that we need to go with a bidirectional or multi-master replication, and there is it's pretty much like a single master multiple slave kind of an approach. So we cannot have MySQL to replicate from different masters into a single slave unless we make changes to the data flow, and it's not advisable to have this multi-master single slave kind of topology until unless we have only one side writing at a time. So with 5.7 and 5.6, actually things got changed, and they have even have this multi-threaded replication slave. So what that means is slave can have the data applied on the target slave in multiple slaves, but unfortunately that's only based on the number of databases you have. So you can have multiple parallel threads for each database. So with 5.7, obviously you can even replicate with multiple threads. If you have like multiple, if you have single database and if you want to make use of this multi-thread replication slave, yes, we can certainly use it. And in 5.7, and something we're going to cover, we can have like a multi-source replication too. So basically the way it works is we can allocate multiple channels for the replication, so we can replicate from multiple data sources into a single slave. Okay, so in order to make sure the data is consistent across all the regional slaves and everything, MySQL has introduced a global transactional identification technology which called GTIDs. So GTIDs are pretty much to make sure the data is reliable and to maintain the data integrity across all the slaves. So it all works fine if we have like a multiple slaves, but let's assume that we have like a series of MySQL forms, like hundreds of MySQL instances in the replication chain. It would be really hard to maintain and manage, to make sure all the transactions are properly applied on the slave, and if we want to do a failover or failback situation, we need to go through all these bin log positions, make sure all the coordinates are matching and all the transactions are properly applied. So in order to avoid this ambiguity and complexity, this GT pretty much helps, and the way it works is the global transaction identifier. So as soon as the transaction got committed on the master, the transaction identifier will be unique across the replication chain. So it will be easier to make sure and identify to which position the slaves or the replicas got in sync, and if you want to fail over and fail back, use and reapply those log entries, it will be really easy. So with MySQL replication, we can have this geographical redundancy, and if you're looking for the DR, disaster recovery solutions, we can have this as a high available DR, disaster recovery solution across multiple data centers, or So MySQL Fabric is a new framework introduced by Oracle. It is very much easier to manage if you have like a series of MySQL forms. So if you want to do like hundreds of MySQL slaves and distribute read-write traffic across, that can be easily done, and we can even have the failover and failback from one node to another within that form of servers. So here is a quick HA comparison of each solution. So MySQL replication also has a Windows clustering failover solution, and you can also have Oracle VM templates and other OS level clustering solutions. So let's talk a little bit about high availability clustering solutions offered by MySQL. So when we say clustering, MySQL has a NDB cluster solution. So when I say NDB cluster solution, it's basically on a network database storage engine. So it's a shared nothing architecture, and you'll have multiple nodes, like a management node, multiple data nodes which will hold the data, and SQL nodes for performing all the SQL operations. There will be client and API nodes for the application needs. So MySQL cluster is a write scalable or real-time ACID compliant transaction database storage database engine, and it's designed to deliver high availability. And with a distributed multi-master architecture, there is no single point of failure, and it scales horizontally on a commodity hardware. We can also have the auto sharding enabled for read intensive and write intensive workloads. MySQL NDB cluster also has a plugin for SQL and NoSQL interfaces. We're going to talk a little bit more about that in the future slide. So another clustering solution is obviously Percona XtraDB cluster. It's from Percona. Basically, the way it works is it's a synchronous replication. It uses the Galera plugin API. So the nodes in the cluster are synchronized with using the single transaction replicas. So as soon as the transaction gets committed and then node, all the nodes hold the same values using the right side replication. So it's basically a group communication group commit technology. So it also uses the GDITs that we mentioned about for this group replication. So the minimum requirement is for the XtraDB cluster is to have 3 nodes, and it should be given with only NODB storage engine supported or XtraDB storage engine. It doesn't support the MySQL storage engine. So there are some limitations available to each clustering solution. I would suggest we take a look at those limitations first before deciding which solution is best for the application. Okay, so MySQL and DRB. So DRB is pretty much like a distributed block level replication. It's basically on the Linux kernel level. So the way it works is the block level storage information is being replicated to the secondary side. So we can have like a master active passive and active HA setup. So it's pretty much on the Linux kernel level, and we can have a HA proxy or CoroSync in combination with MySQL and DRBD for a faster failover and failback situation. So apart from that, we have like cloud-based HA solutions available with Amazon for RDS and EC2 instances. So you can have the multiple zone level HA solution and replica sets available if you're looking for a faster failover and data sync operation. So MySQL also supports the Windows-based clustering solution, but unfortunately it's not a shared nothing thing. So we need to have like a shared drive and separate hardware and libraries. Drivers are needed to make sure we do this Windows-based clustering. So Oracle Enterprise VM templates are available if you're looking for an enterprise cloud-based VM solution. So for faster failover and failback scenarios. Okay, so let's talk about some of the scalability features of MySQL. So with MySQL replication, we can have this read-write data sets distributed across multiple nodes, and we can have the reads mainly use slaves. We can have the MySQL slaves for the read request, and writes can be only sent to the master. So there is another plugin available which is still under development with Oracle on the MySQL Labs. So it's called a group replication plugin. So it's pretty much the way it works is similar to the Galera plugin. And MySQL supports multiple CPU cores, so we can have this scaled for the both high read and write intensive workloads. And MySQL supports both partitioning and sharding concept. So if you're looking for the enterprise cluster, NDB clustering solution, it also supports auto sharding methodology. So most people would ask, how do we know when should we start scaling? Well, if you ask me personally, MySQL, a single standalone MySQL instance can support up to 250,000 queries per second, and of course these are on the commodity hardware, and of course depends on the transaction size of the application and how you define the caching layers in between. So if you take a look at the stats, the numbers or the benchmarking numbers results are from Oracle. So it's pretty fascinating and amazing to see how a single MySQL instance can scale up to. So okay, so let's talk about some of the performance metrics that we have in MySQL. So MySQL has this optimizer settings that would allow us to make sure we get the data whenever needed in a much high performance rate. So unfortunately, the MySQL optimizer settings are not rule-based optimizers. They are pretty much on the cost-based optimizer, and there are some optimizer enhancements made to make sure we can define some rules on a per session level. Okay, so MySQL in MySQL 5.6, even in 5.5 we have the information schema, and starting with 5.6 we also have the performance schema objects. And the way the performance schema objects work is it provides instruments for memory, transaction, storage, and even for MySQL replication metrics. So we have, unfortunately, until 5.6 we don't have metrics available for these kind of information. So with performance schema, this is one of the main demanding requirement for quite some time. Now we have a place where we can look for these performance metrics and instruments to observe and understand what's happening inside the database engine. So there is also a schema available. So basically the way this schema works is pretty much like a helper object. So we can keep an eye on the database health and keep track of the performance metrics. And if you want to get some specifics about how the IO is getting distributed across multiple objects and everything, we can certainly capture and gather all that information and generate some reports. That's a pretty handy and useful. So if you're looking for some benchmarking tools within MySQL, yes, there are tools like MySQL Slab available where you can reapply and simulate the traffic that you have on the production. And if you're looking for multiple workloads, we can simulate that to multiple connections, multiple CPUs, and uh, you can simulate the real-time traffic that you got and reapply on the database to make sure if you're reaching those performance metrics. And there are also tools available with this bench and Percona tools that would be very handy too. So if you're looking for load balancing, for rerouting the traffic and balancing the read-write split and failover the traffic from one node to another, so MySQL proxy acts as a proxy to reroute the traffic, and we can define the backend database nodes and depending on the scripts that you're going to configure. So there are so many development plugins and connectors available for MySQL. So it supports all major development languages. So the connectors and APIs are available for almost all application programming languages out there. The cool feature is it also supports the JSON file format in the latest version. So it's pretty cool. So let's talk about how the backups are made within MySQL and what options we have for backup and restore and recovery scenarios. So if you're looking for the logical backup strategies, MySQL has multiple utilities called MySQL dump and MySQL dumper or loader. So MySQL dump is pretty much like a single-threaded logical backup solution. So you can have the backups into a single file, and based on the instance level, table level, or database level, however we want to do this and reapply those backups. So because it's logical backup and it's not like a hot backup, I mean, there are certain storage engines that we can have like hot backups, but unfortunately for MySQL storage engine, you might have to route those. It's not hot actually. So if you're looking for actually hot backup or physical hot backup solution for consistent backups, there are tools available called MySQL Enterprise Backup, and Percona also has Percona Extra Backup, using which we can take enterprise level backup solution, and it's pretty much like a hot consistent backup. It's pretty much on the instance level, and we can take it from the database level too. So if you're looking for snapshot level backups from the operating system, there are LVM snapshots and file system snapshots available for MySQL data directory, and we can certainly make use of them. Unfortunately, those are not actually hot backups, so that's something we might have to consider. All right, so let's see what MySQL has to offer when it comes to the security. So there are multiple security layers that we can define within MySQL. So if you want to limit the access of the database from specific port and for specific user group and from specific IP range, we can certainly do that, and we can limit the access to the database to the core of a specific user host specific level. And the way access controls works is we can have the specific role and privileges defined. So only the users with proper privileges can get to the database, and they can only see the specific objects that they were given grants for. So MySQL supports the secured password hash authentication and hashing methodology. MySQL also has the encryption and decryption functions available if you want to encrypt the communication, or if you want to encrypt the data or the files, we can certainly do that too. So there are plugins available within MySQL, so we can have the password validation and password authentication and expiration policy set. And that's the beauty of pluggable storage engines, and we can continuously enhance it and add as and when needed. So if you have looking for enterprise level authentication methodology, MySQL also supports the PAM authentication and LDAP integration, but unfortunately that's something available with the enterprise model. So you're looking for some integration into your already existing LDAP system or single sign-on, you can certainly do that too. And there are some third-party open source plugins available if you're interested. So let's talk a little bit about the buzzword big data. So it's now there everywhere, and uh, let's see what MySQL has to offer when it comes to the big data methodology. So the key concepts of any big data technology is, first thing is to acquire the data. With the demands for the requirements increasing and we're getting these gigantic volumes of data day by day, the key is to gather the data from multiple sources. Okay, we acquire the data from different sources. The next thing is we need to organize the data. Well, organizing the data is it's a little bit tedious, so we need to make sure the duplicates and everything will be, and we need to consolidate the data. So, and once we have the data organized, then the key is to analyze the data. So how do we process the data? Make sure we can use any kind of tools like MapReduce or anything such as a to analyze the data, and we can process them to the Hadoop cluster or anything on a store, and then deciding on how we want to use the data, whether we want to use the client's data to generate some reports, or how we want to present that to a single database store, and for warehousing purposes we can certainly do that too. So let's see what MySQL has to offer for this. So MySQL also supports the NoSQL plugin for NoDB, and that's something we can integrate into the MySQL plugin, and you can have the non-structural data stored within MySQL. So MySQL also supports the Hadoop integration. So if you want to process the Apache Hadoop files store and into the database, MySQL database, we can certainly do that. So MySQL cluster, the MySQL NDB cluster also supports the NoSQL API. So that's like an interface for both the structured and non-structural data. So we can have that integrated into the NDB cluster and use that for data store. So MySQL supports the JSON file format. So we have a JSON functions and like a JSON extract and JSON search available and supported within MySQL. So there are also plugins available for MySQL to store this NoSQL data. So if you go to the Percona version, there is a handler socket NoSQL plugin API available, and we can integrate that into the MySQL data store. And if you're looking for the MariaDB plugin, there is a Cassandra NoSQL storage engine or API that's available. You can integrate that into the MySQL database. Okay, so we know we have the data and we have the services up and running, but we need to make sure what we should monitor and how do we monitor, what options we have for monitoring MySQL instances. Well, there are so many enhancements done, and there are many open source tools available for MySQL. If you're looking for the open source tools, there are plugins for Nagios, Cacti, and Zabbix from Percona, and those are pretty fascinating and they're pretty useful tools. They were well built and matching all the requirements. So if you're looking for the dashboard level trending historical information to be able to view what's happening within the database, there are tools like Munin and Control Base available. If you're looking for the enterprise level model, MySQL Enterprise Monitor is pretty handy and useful. So we need to have the enterprise management console and agents distributed across each node. That's really handy. And there is another tool called Monyo from WebYog, and Vivid Cortex is much more enhanced and pretty useful too. So let's talk about some of the tools that are available for MySQL for performing these day-to-day operations or DBA support. So there are MySQL Workbench utilities available from Oracle, and if you're trying to migrate the data, and there are migration toolkit available, and if you want to clone one of the MySQL instance to be able to perform your data refresh activities from production to QA and dev, we can have tools for MySQL server clone, and if you're trying to replicate it's a form of servers from one node to another, there are tools for MySQL failover, and there are some limitations and dependencies associated with each of these tools. So I would suggest go over the documentation first before using. And uh, there are Percona tools available. Those are pretty handy too, and those are kind of lifesavers for any DBA to have them. So PD online schema change and PD query digest, and if you're looking for PD online schema change, is very much very useful to make online schema changes. There are some cases where uh, making the online DDL changes is not compatible for some specific storage engine. So I would suggest we go over the documentation first too. And PT table checksum and PT table sync are pretty handy tools available. So if you for some reason if any of the master or slave they got out of sync due to some data inconsistency, these tools are pretty handy and useful to sync back the data and even to validate what's happening and why they were out of sync. So here's a quick overview of the limitations of MySQL, and these limitations are pretty much varies from storage engine. So I would suggest we go over the storage engine documentation first to understand what are the limitations are associated. Okay, let's talk about some of the enterprise solutions available with MySQL. So over all these years, Oracle has made tremendous improvement to the enterprise model of MySQL, and we can have all varieties of enterprise tools available within MySQL, starting from MySQL Enterprise Monitor to Enterprise Backup and Enterprise HA solutions. MySQL also offers the Enterprise Authentication Protocol, and Enterprise Authentication, we can have the Enterprise Firewall and routing mechanisms too. It also offers some MySQL auditing methodology, so we can capture all the activities that are happening inside the database and use them. If you're looking for any SOX or auditing reports, we can certainly have them reviewed. So this is one of the most awaited release that's called MySQL 5.7. It's available in GA, I think in last couple of months, in October, I believe. So let's take a quick overview of what new features has to offer in this 5.7. So obviously, one of my favorite is a multi-source replication. So we should be able to replicate from multiple sources into a single slave. So that would be very useful if you have multi-regional data source, and if you want to generate some reports out of those multiple regions. And it also supports the JSON file format, so we have this NoSQL file structure and Java support too, so that's good. Enhanced GTID, so until 5.6, if you want to roll over from non-GTIDs to GTIDs method, unfortunately there is no way we should be doing it online. So within 5.7, they have enhanced it, so we can roll out the GTIDs online without bringing the entire cluster or services down. So MySQL 5.7 also supports the virtual column, so it's pretty much like a functional or functional based indexing kind of generating reports that could be really useful. So MySQL pump is multi-threaded MySQL dump. I would say we could relate that to. So we can have the logical backups done in multiple threads instead of a single thread. So there are a number of optimizer enhancements, and there are tons of feature added to MySQL 4.7. So Oracle claims that it's 3 times faster than the MySQL 5.6 and can support pretty fast and vast database traffic for both the read writes and transactions. Okay, so most people are not aware, okay, we have the MySQL instances running, but we don't know what level of support we get for MySQL and what options we have. So obviously, with every software, there will be bugs, and Oracle and all the open source community groups are putting efforts to make sure any bug-related information is fixed as soon as possible and as quickly as possible. And there are frequent security patches from Oracle. So I would suggest we go over those security critical patch updates and keeping an eye on those new enhancements and bug fixes. So keeping MySQL versions up to date is obviously one of the most recommended thing. And there are many open source groups available. If you're looking for the Oracle community groups or Percona community groups, they're pretty helpful, and they're pretty quick in responding. And, if you have some issues with any of the product, and uh, it's invaluable. Okay, there are community groups available, and if you're looking for enterprise level support, there are two. Oracle offers enterprise level support, and even we have Percona and MariaDB have enterprise level support models, and we can even refer to kind of one of the companies like Datavail to have the support services taken care of. Okay, let's talk a little bit about the customer case study. So we have a customer that we helped migrate to MySQL, and they are a Fortune 150 company, and they are a major player in the electronics parts manufacturing, and they have like a 16,000 employees worldwide, and Datavail supports the MySQL environment. They were having issues with the scaling. They have these multi-data stores across the regions, and they have multiple geographically located services, and they were unable to keep up with the data load operations and everything. So we helped them migrate from MySQL 5.1 to 5.6, and we were able to help them provide a geographically redundant and distributed disaster recovery solution without compromising on the performance, and without having to worry about the downtimes and everything. And we help them save a lot of operating cost and database licensing stuff. Here is another quick case study about a customer. So this is a financial services company with 300 million revenue. So Datavail supports this MySQL Enterprise. We help them migrate from Oracle to MySQL 5.6, and again, this is a geographically distributed, higher availability and scalable solution, and it's very fascinating how the complexities of the current system got resolved with MySQL, and they were able to solve. They were able to save thousands of dollars without avoiding this enterprise licensing, and able to and scale the current application. All right, I think with that we conclude the presentation today, and we really thank everyone for joining us today, and I will be happy to answer any of the questions you may have.
We had a few questions come in. Our first one is there any equivalent to SQL's clustered column store indexes?
Sorry, could you repeat that?
Sure. Is there any equivalent to SQL's clustered column store indexes?
So the way I understood is the question was asking whether we have any column store indexing, clustered column store indexing.
Correct. And is there any equivalent to that?
I would say the functional-based indexing that's available in 5.7 is kind of related to that, and if you want to store the column data, I mean, you can have the virtual columns in there, but unfortunately, the functional-based indexes are not entirely supported. But that's something we could closely relate to. That's what we're looking for.
Great, thank you. Our next question, is semi-sync like SQL's synchronous replication with availability groups?
Semi-synchronous replication is like SQL synchronous replication with availability groups. So semi-synchronous replication is pretty much like a plugin that we have. We would enable it on both master and slave side. So the way it works is, as soon as the transaction gets committed on the master, so there would be an event sent out before it's committing to the database. There would be an event sent out to the respective slaves, and the slave would acknowledge whether the transaction is received by the slave. So as soon as the transaction is received, it will send an acknowledgement back to the master saying that, okay, we are good, we received the transaction, and then it would be committed. So that's the way it works with the semi-synchronous replication. And if you're looking for a synchronous replication clustering solutions, there are available like the Percona XtraDB cluster and the NDB cluster. MySQL NDB cluster is also a synchronous replication HAS solution. Yeah, but
Wonderful, thank you.
with MySQL replication, it's so far it's pretty much like asynchronous and semi-synchronous, and in 5.7 they're working to make it virtually synchronous with group replication.
Great, thanks. Our next question, what is the use of storage engine? Can you please explain in terms of people who are not from MySQL background?
Sure, certainly. So the way the storage engine concept works is, so basically we want to relate that storage engine is how we want to store the data inside database. So not every type of application needs would have the same requirement. So let's assume that if you have a read intent non-transactional application and you want to only have the read-only transactions, read-only traffic available for reporting purposes, then I would suggest going with the MySQL MySM storage engine. So it doesn't support transactions, but it's pretty fast. When I say fast, it's extremely fast, and if you try to compare the stats, it will be amazed to see how fast it is. And if you're looking for the transactional storage engine, obviously we go with the InnoDB that supports both for transactions, foreign keys, and everything. And again, as I mentioned before, there are tremendous improvements and enhancements made to InnoDB to make sure we deliver the same performance metrics as MySQL. And so if you're looking for archival data, obviously there are storage engines available for CSV, and there are other storage engines like TurboDB and Federated. So each storage engine has its own specific. So it's not like we have to have a single storage format for all the type of data. So that's flexible, and you can migrate from one storage engine to another storage engine anytime. So I would suggest probably we could have another presentation on a more detailed discussion about what each storage engine has to offer and what are its advantages and disadvantages in future.
Thank you. Our next question, do you see any clients using Maria database rather than MySQL?
Sure. So there has been a lot of improvements put into the MariaDB, and it's pretty much like enhanced MySQL, I would say, a fourth version. So MariaDB has a lot of plugins available when compared to MySQL. So if you take a look at the plugins for NoSQL, and there are I would say around 64 varieties of storage engines available, and even I would say the multi-source replication and all these group parallel replication features are there in MariaDB 5.6 before itself. So those are not in MySQL 5.6, but MySQL and Oracle, they're trying to integrate those things, and they're making efforts to make sure all these features are available in 5.7. So that's why I would say MariaDB is far better when it comes to the all these various features and enhancements. But in MySQL 5.7, we certainly have most of those features and enhancements incorporated into. Hope that answers your question.
Thank you. Our next question, we are planning to move from 5.1 MySQL Percona server to 5.6 Percona extra database cluster with minimum downtime. How will going to this affect our functions, store procs, views, and triggers?
That's a good question. So if you have a MySQL 5.1 data store, and if you're trying to migrate from 5.1 to 5.6, Percona DB XtraDB cluster with minimal downtime, and I would suggest, it depends on the type of storage engines that you have currently, and there will be definitely if you have both mix of MySQL and InnoDB in the current 5.1 environment, and we are looking to migrate to 5.6 per connect cluster. I wouldn't suggest migrating with the same MySQL storage engines to 5.6 because there are some issues, or it doesn't support the huge transactions. So if you have huge transactions or mix of transactions for both MySQL and InnoDB, those are not, I would say, not advisable to directly go, and it definitely needs some testing and make sure all those non-transactional and transactional mix would be removed, and make sure we convert or migrate from MySQL to InnoDB and bring the transactions as minimal as needed. So then there are some functions and store procedure dependencies available too. So I would suggest we go over that and how they are defined. If you have like a recursive store procedures called by triggers and functions, then that's something we need to definitely take into consideration.
Wonderful, thank you. Well, that's all the time we have today for questions, but if you do have any follow-up questions that come up, please feel free to direct those to speakers@ioug.org. And at this time, we'd like to give a big thank you to our speakers today. Thank you, Krishna. Before we conclude, please make note of our upcoming webinars and past webinars by visiting www.ioug.org. A recording from today's webcast will soon be available in the Resource Center. We'd again like to thank our speaker and everyone online for attending the event today. There is a survey after this webinar for you to complete. We thank you in advance for your feedback. Thank you again for attending today's webcast, and have a great day.
Thanks, everyone. Thanks for joining.